Okay, so we're starting something a little bit new. This will be on your next test. There's going to be sequences and series, and then we're going to start doing summation stuff, all this good fun stuff. So in terms of why this is important for pre-calculus, it's super important for if you decide to take BC calculus. This is like a Calc 2 topic. So yeah, that's about it. Let's move on with our lives. Okay, let's write down the first 4 terms of the sequence. So if a sub n is the numbered term that you're on. So if I want to do the first term, I would plug in a what for n? A 1. So what is a sub 1? 3. What is a sub 2? 5. Again, we're just plugging in numbers. A sub 3? Plug in a 3. 7. A sub 4. 9. Without even looking at this function whatsoever, what's the pattern? It's all odds going plus 2. Plus 2, plus 2, plus 2, plus 2. So if you had to figure out a pattern, which we might need to do, coming up a little bit later on in the sheet. Okay. So for number 2 here, I gotta find out what a sub 1 is. So plug in a 1. What happens to this? This negative 1 just means it's either going to be negative or positive. Do you agree? Nothing else is going to happen from it. So is this going to be a negative or a positive? By plugging a 1. It's negative divided by 1. So what's 2 plus negative 1 over 1? It's 1. Plug in a 2. What do you get? You tell me, I can't do math. Three halves. Plug in a 3. One third. What about a 4? This one's a little trickier to figure out this pattern. Well, it happens in the denominator, it just adds by 1 every time. And then the top one just alternates 1s and 3s. So that's what it is. Top alternates 1s and 3s. Who just whatted me? What did you just say?
Stupid pattern.
You take your Bears hoodie and get out of here. Okay, so we can also write stuff recursively. So recursive is when I give you the first term, and then we always have to use the previous term. So there's 2 different types of sequences. There's explicit, which is what we usually do, and then there is recursive. Recursive starts with the letters RE. What does RE mean, like in English? Again, right? So you keep using the previous one, like again, and again, and again, and again. Okay, so that's what that is. So if I want to write, what is this asking me? Write down, blah, 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 blah. Oh, so I think so what's the first 4 terms, I think. So let's go ahead and do the first 4 terms. Well, it gives us the first one. What's the first one? Which is 28. That's cool. A2. Oh, I wrote it backwards. A2. I'll kind of go through this. So A2 is going to be when k is equal to what? 1, correct? Do you agree? That A2, in order for this to be A2, I need to make k into a 1. So this equals A1 plus 3. Well, what is A1? Plus 3 is 31.
Can you do that again? Can you just say it?
Okay, so to get to A2, k equals 1. Do you agree? Because 1 plus 1 equals 2. Okay. And then you're going to get A1 plus 3. So A2 is 31. So for A3, what is the k value?
2.
Yeah, it's always going to work out this way. It's just always going to be the number previous. So it's going to be A2 plus 3, which is 34. A4. Well, do I need to write that everything down again, or do we get the idea? I'll write it down. So it's going to be A3 plus 3, which is 37. So this looks really fancy, but what's the pattern? It's just increasing by 3. And that's exactly what this is saying. This is saying take the previous term and add 3.
Okay.
That's all that means. Take the previous term, add 3. I'm not a fan of the notation here, but we'll just have to live with it. Okay, so for this one right here, well, why don't you try this one on your own? You do the first 4. What's A1, A2, A3, A4? I'm going to ask on random people, at random tables, for random answers. Alright, are we ready? Here we go. The toughest one. Asher, you got this. What's A1? What's A1? It says it right here. You're just not listening. You got headphones in your ears. Headphone in your ear. Maybe headphone and ear is a bad idea. Maybe headphone and ear is bad idea. Me not English teacher. Me math. I've been talking like this all year and you haven't picked it up yet? Okay. One more time, Hesher. What is A1? How do you know that? It's given to you. That was a lot longer than I really had planned on it being. Natalie, what's A2? How'd you know that? Because you just take the previous one, multiply it by 1/2? Cool. A3 is going to be what, Cindy? 8. Krishna, A4. What's the pattern? Everything's getting divided by 2. Okay, so let's start to kind of work in the other direction. So I've been asking every single time, hey, what's the pattern, what's the pattern? Because I want to get you kind of familiar with what the pattern is. So now we need to write an expression for the nth term. So you're given parts of the sequence. So the first number is always when n equals 1. Second one is always when n equals 2. Third one is when n equals 3. So I'm going to give you just a moment here. If I just tell you, it's not as fun. So I want to give you a quick moment here to kind of think of what 5 is, what the pattern for 5 is. So it's a sub n equals what? And these are going to be all explicit. None of these are going to be recursive. So yeah, kind of like for number 1, if I gave you 3, 5, 7, 9, the answer would have been a sub n equals 2n plus 1. So I'm giving you this, and then I'm asking you this. Yeah, I'm not a fan of the notes, because they kind of just stick recursive right in there. We ignore it recursive for a little bit. So, given these 4, or even like this one was harder for number 2. Figure out what that pattern is. If you're done with 5, just move on. But I do kind of want to figure out what 5 is. I'm going to give you about 30 more seconds. We'll see if anybody can figure it out. What is going on? You know what's going on? Okay, well, I'm going to wait. No spoilers yet. I want them to think. Torture themselves. Think. 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 Oh, you can hit pause on the video if you want. Think. And Diana, what'd you get? Does that work? So plug in a 1, you're going to get 2. Perfect. Plug in a 2, you get a plus 1, which is? Perfect. You plug in a 3. 9 plus 1 is 10. So all of these numbers are just one number higher than a perfect square. That was brilliant. What do you mean wait? Why should I wait?
She's done this before. Okay, see, I don't know the pattern. Like, I just want to know how to do the equation to get to that pattern. Like, I already see the pattern in number 6, but like, how do I?
Okay.
Oh, would you just multiply it by 1/2?
Number 6. Let's look at number 6. Look at number 6. 1/2, negative 1/4, 1/8, negative 1/16. Just look at it and think about it. For those of you whining and complaining, stop it. Okay? You just need to train your brain a little bit. It's okay. My son is 4 years old and he does not know how to write the letter N. He still cannot write the letter N. But he's much better at it now than he was earlier because he had trained his brain how to do it. He just kept practicing it over and over and over again. So, just this, like any other math concept, if you don't get it right away, that's normal. You just need to keep training yourself to do it over and over and over again until you are perfect at it. So, looking at 6.
Where does he go to school?
He goes to a private school in pre-K.
I said, because Avery goes, I don't remember learning how to write at 4.
Oh, public school people. No, my kid's going to go to public school too. It's just public school doesn't offer pre-K. And, okay, they actually, that's a new thing now. And they offer it only for certain situations. Economically disadvantaged, veterans, if they have something called an IEP. We're learning so much in this video. We're learning more about life. Okay, before I ask you what the sequence is, who can predict what the next number is going to be? It's 1 over 32. So we know what's going to happen. How do we write it down mathematically? Danielle, you said you got it. I'm giving you the floor.
No, not in front of everyone, because what if I get it wrong? No, I don't want to say it, because then everyone's going to just...
All right, talk to your table.
What'd you get?
What'd you get?
Isn't that right? Because then if you multiply by
I'm excited. I really think you got this. I'm really excited for you.
How am I wrong? Are y'all wrong? I got negative 1/2. Why can't you plug in the negative? Hold on, it's split. Because look, 1/2 times negative 1/2 is negative 1/2. Then times negative 1/2 is positive 1/8. Because negatives cancel.
Okay. All right. You get negative 1/2 to the end.
Negative 1/2 times n.
So negative 1/2 times n.
Yes. How am I wrong?
I'm gonna help you out here. You're close.
Okay.
If you times it by n, okay, I'm gonna help you. I'm here to help. If you did negative 1/2 times n, when n is 2, you would get negative 1. So it can't be times.
I didn't do it right.
Can't be times.
I was doing the actual number by the...
But you're close though. Like what can I do to help her out here? Like this is so close. To the n. This is also very close. Because when I plug in a 1, I get a negative 1/2. When I plug in a 2, I get a positive 1/4. I'm just off by the sign. How can I change that? Not negative n.
N over 1. 1 over n.
Plus 1?
Oh, shoot.
Which, Daniel, actually is what you just said, kind of. Right? Or no, does this even work? Okay, so I fixed something. I didn't fix everything. Let's see, you just need the correct sign now.
I don't know. Just ignore me.
Alright, what's yours? This is not correct, by the way. This is not finished. I want to hear yours.
I said an equals negative 1 over negative 2 to the n. And negative 2 is in parentheses, so the n is the whole.
So at 1, you would get negative over negative, which is positive. At 2, I like this one. I like this one. Okay, so
Okay, that's, I don't know how he did that.
okay, so all I'm trying to get at up here is this one's not correct, by the way, because I just hadn't fixed enough of it yet. But if your sign's ever off, you need to either add or subtract by 1, and that will fix your sign issue. But then you need to fix your coefficient issue, because in this case, if I plug in a 2, I'm going to get a negative 1/4, and that's just not right. So how can I change? Or no, I'm going to get a positive 1/4. How can I change a positive 1/4 into a 1/2?
Can you not throw a negative on the front instead of plus 1?
Multiplied by 2.
Literally no point.
Oh, so you're saying another one could be if you did this. That would work. Alright, I give you 3 correct answers here.
Does anyone see what I did wrong though? Like, I wasn't doing 1 and 2. Like, I wasn't plugging in 1 and 2. I was plugging in.
Yeah,
1
so what happens for yours was we need to multiply it by a scale factor. To multiply by a scale factor, that has to be an exponent. You were just adding by the same number every single time, whereas this isn't a linear. It doesn't add linear. So what you did, if you're multiplying by an n, so for examples like this, okay, this looks just like this. Do you agree?
Yeah.
That's a line, so it's linear. So if you ever just multiply by the n, it becomes a linear series or sequence, depending on what else is going on. This one is an exponential one, because if you notice, it's exponentially increasing. So it keeps multiplying every single time. That's exponential. So you need an exponential as your answer. Alright. Try 7. It's kind of like 6. Try 7.
Are any of these going to be like the one where you're given the first value and then the next one is based off of the first? Like the A.
No, none of them. Which is why I'm confused why they just threw a cursive right in there. Talk to your table. Hey, they're all tables now. This is so nice. Talk to your table. See what you're getting. How can you fix somebody's? What can we do? One works. 2 works. 3 works. You're good. Alright, shh. I'm going to reel you back in here. Does anybody know what the next number is going to be? 16 over 81 times 3, so we kind of get the idea, right? So is this increasing exponentially, or is it increasing linearly? So we need an exponent, at least one exponent in our answer. What's happening to the top and the bottom? The top one increases by how much each time? A 2. The bottom one increases by what each time? A 3. So it's kind of sort of like this. Let's fix it from here. Okay, so the bottom one is 3, then 9, then 27, then 81. So we agree that it's just 3 to the end on the bottom. On the top, it doesn't start, the 2 doesn't happen until the second number. And then it starts, and it's doubling every time, but the 2 doesn't start till the second number. So I can't put n, because if I put n, that means that the 2 would start here. So what can I do? N minus 1. Now, on the first one, we get 1 minus 1, which is 0. 2 to the 0 is, that is so amazing. 2 to the 0 is 1. Alright, look at 8. Look at 8. This one should not take too long. Alright, we figured this one out. This one, to get to each number, are we multiplying or are we just adding? Adding, so this is linear. How much are we adding by? What do I start at? I start at 1, but if I put a 1 there, is that going to work? Minus 3. I'm teaching you to think. So, this increases by 4. So that's how I know it's 4n. And then you got to figure out the first number. Well, when n is 1, I get 4. 4 plus what gives you 1? Negative 3. Well, we're going to find out. Alright. Okay, so let's do the indicated terms. So all I have to do is just plug in the numbers. So here I'm giving this to you and saying, hey, find a sub 16. All you do is you plug in a 16. So you're going to do negative 1 to the 16 minus 1 times 16, 16 minus 1, which is negative 1 to the 15 times 16 times 15. Negative 1 to the 15 is... It's what? Negative 1? Okay, so it's negative 1 times, what's 16 times 15? For those of you totally lost, do what my 4-year-old does and multiply like this. Kidding, he does not do this. He can count to 20-something. Very proud of him. You add that up, and you get 240, negative 240,
This is what my 4-year-old does on the weekend.
Actually, his teacher gives us like a little activity. They have something called tabletop activities. So like when it's like free time or whatever, they get like a box of like an activity to do at their table. So last week we had play sticks. It was called. It's kind of like, you know what Lincoln Logs are? Yeah. It's kind of like that, but there's like ridges on every single end. But you can build stuff. So I taught him how to build a bed, and then he went to school on Monday, and then he built a bed. He was so happy. Want to see it? I can show you it. I have it. I have it on my phone. I was so proud. It's gonna be on the video. I'm probably gonna have to pause the video. We're gonna pause the video. I can't. And we're back. I don't think so. All right. Hey. Shh. You get the idea for number 10, right? Do I really need to plug in a 13? We get the idea? Did you get 37 over 130? Okay. You can try this one on your own at home. Does the top one factor and cancel? I think the top one factors and cancels. I believe so. Alright. Alright. Okay, we need to talk about factorials. Have you ever seen this before?
Yeah.
Some no, some yes. So factorial is a rule where you're just multiplying up to that number. So like it's probably easier to start from 5. So to get to 5, you're gonna do 5 times 4 times 3 times 2 times 1 equals 120. You do all those numbers. 4 factorial is 4 times 3 times 2 times 1, which is 24. 3 factorial is 3 times 2 times 1, which is 6. 2 factorial is 2 times 1, which is 2. 1 factorial is 1. We don't do negative factorials. And 0 factorial, that's just a rule, is equal to 1. There is a proof somewhere on Google. I used to know it pretty well. I kind of know it, but I'm too shaky on it to show you. So, I mean, I guess I can Google it, but I'm sure you don't. If you want to see the proof, comment below. No one's going to comment.
I'll comment. I'll go comment on it right when you post it.
No, you're not. No, you're not. I'll just write in the comment the proof. I'll comment with the comment. Okay, write the first 4 terms. Same thing that we just did before, but now we're going to add in the factorial. And factorials have like totally cool, unique properties that we're going to get to in just a moment. So, A1. So, A1 is going to be 3 to the 1, which is? It's 3 plus 1, which is? All over 1 factorial, which is? 1, which equals 4. A sub 2, 3 squared is? 9 plus 1 is? So it's 10 over and 2 factorial, which is? Which equals 5. I don't know. I thought I started it. 3 cubed is?
27.
Plus 1?
28.
Over n factorial? Which is? 28 over 6, which is? 14 thirds.
Where'd you pull that number out of?
I divided the top and bottom by 2. A4 is?
81. 81. Huh?
Oh wait, you know what? It doesn't want. I can't read. It doesn't want A4. It wants the first 4 terms starting with 0. So let's add this up right here. What's A sub 0 going to be? I really need to read more. It says beginning with n equals 0. That's stupid. You should always start with the same number. So you're going to get 3 to the 0, which is?
1.
Plus 1, which is?
2.
All over 0 factorial, which is?
1.
2 over 1 is?
2.
2. So there you go. There's your answer. Reading, that's important. Okay. Alright, so evaluating factorials. I kind of want to show you a little bit of a trick. I'm just going to show it to you for number 12, and then you'll see you can kind of figure it out from there. So, for factorials, the key is, it's so difficult to do 9 times 8 times 7 times 6, and you don't want to do that, okay? Get really, really high numbers. So, you want to rewrite 9 factorial so that it has a number on the bottom. Typically, I want to write down the number on the bottom, the higher one. So 9 factorial degree is 9 times 8 times 7, 6, 5, 4, 3, 2, 1, right? What is 7 times 6 times 5 times 4 times 3 times 2 times 1? 7 factorial. The reason I do that is so that I can cancel out the 7 factorial. So what's 9 times 8? 72 over 3 factorial, which is? So this is equal to? 12. And this is kind of where probability stuff comes from. You don't learn this stuff in like the stat next door, do you? I don't
Yes.
think so. Yes? Do you do probability in stats?
Yeah, we do. We don't learn factorials.
Yeah, you do probability. All right.
Yes, a lot of probability.
But not like this. So like tells you what the probability is.
Yeah, we just enter the probability.
Okay, tree diagrams. Ooh, that's fun. And then like you have like the unions of probability stuff. Yeah, okay. All right, so let's look at 13. All right, can we break the 3 down to get rid of one of these 4s? Okay, can I break the 8 down to get rid of one of these 4s? Okay, sure, let's go ahead and do that. So this is going to be 3 factorial times 8 times 8 times 7 times 6 times 5 times 4 factorial. All over. Now, can I break one? So one of these 4 factorials is going away. Can I break down one of these so it knocks out that 3 factorial? Sure. So let's make this first one 4 times 3 factorial times 4 factorial. So now we go bam, 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 bam. And we're going to get 8 times 7. Actually, is there another number I can knock out real quick? Can't this 8 turn into a 2 if I take away that 4? At math, that's what we do.
Okay, y'all have a ridiculous rule. Yeah. Because y'all are like, oh, that's illegal, like, you can't do that, but that was pretty illegal.
Anything that's multiplying can be canceled. You start throwing in plus signs, illegal, left and right. So 2 times 7 times 6 times 5. It's 420.
I'm so sorry, the way you said it.
I'm not writing down 420. That's just the answer. All right, this one right here. This one's going to give us a letter as an answer, and that's okay because we have letters. So let's kind of do the same thing. Which one's bigger, n plus 1 factorial or n factorial? Okay, so I'm going to keep writing down the n plus 1s until I get to the n factorial. So this is going to be n plus 1 times n factorial on top. Do you agree with that statement?
Sure. Yeah.
You don't believe me? Here we go. If I have this, very similar problem, right? It's bigger by 1 on top than the bottom. This is equal to 6 times 5 factorial over 5 factorial. You agree? Yeah. And then you would just cancel that out. Same thing here, but I have letters instead. So I'm going to have n plus 1 times n factorial all over. So it cancels out. So you're left with n plus 1. I love this. I'm going to give you a 14b. I want to see if you can do 14b. Simplify this one. N plus 2 factorial all over n factorial. Confident enough to say it out loud in about 30 seconds? Okay. All right, who wants to offer up an answer they have? Monica. I agree.
That's what I got. Oh, yes.
Well, yeah, right. That's not what you got. Yeah, you just wrote it down.
I can never be praised for my
So whenever we do this, it's going to be n plus 1, because remember, we're decreasing by 1 every time. So it's n plus 1 times, n plus 2 times n plus 1 times n minus 1, blah, 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 which is going to give you the n factorial. The reason I stop at n factorial is because I have n factorial down here. Cancel that out, and then boom, answer. Some people are like, wait a minute, can I simplify that further? You don't have to. Okay? Please take note of that. A lot of you struggled on your quiz yesterday, or whatever class it was, 2 days ago, because you had the correct answer, like, I'm going to go further, and you did something wrong. You do not need to multiply things out like this unless it says to do that. The answer is totally fine by me. Hey, last thing, like, this lesson jumps around all over the place. Like, I'm being completely serious. I have taught this one lesson into 4 different lessons in the past. So, if you're saying to yourself, this is a lot, it is. I'm on team whoever wants to complain. Daniela. I'm on team Daniela. Hey, what a team to be on.
What do you mean?
I'm so happy to be on team Daniela. I'd rather be on my team. I'm a leader. I want to be on anybody else's team. You don't even say my name right.
Coach Meidenbauer. Shut up. I didn't say it wrong.
All right, so let's go through this. Summations. Have we seen this before?
I've seen it once.
Okay. What it is you start at the bottom number and you plug it in. Plus the next number. Plug it in. Plus the next number. Plug it in. When do you stop? When you hit the number at the top. Okay? So, this is going to look like this. Plug in a 1. So I'm going to get, by the way, it'll tell me. So I'm plugging in a 1 for I. So I'm going to get 4 times 1 plus 1. Plus 4 times 2 plus 1. Plus 4 times 3 plus 1. Am I done yet? I have to go until what number? 4. Okay. Plus 4 times 4 plus 1. So that's me expanding it. Anything to remember anything? What is 4 times 1? Plus 1. 5.
Oh, shoot. I thought you were
What is 4 times 2? Plus 1. 9. What?
He said 13.
Sure, the next one is 13. What's one after that? 17. Let's add these all together. Well, I know this makes 30. And I know this makes 14. 30 plus 14 is? 44.
Wow.
Ooh.
An avocado.
I don't get it.
You've never seen that Vine where they're practicing the kid opening Christmas presents and his good reaction goes, an avocado.
What's a vine?
He's lying. Shut up.
A tree? Tree vine?
You know what a vine is.
Wow, I'm glad you think so highly of me. Alright, hey, last one. What number do we start off at?
2.
End at A. Try it on your own. We'll end this 40-minute video. Well, I'm sure like half of it was me talking about nothing. They usually are. Hey, would you rather do this in like 30 minutes, boring, or me spice it up a little bit? Yeah, see, it's a long class. If it was a shorter class, I'd probably go straight through. Did we get 2 through 2?
I did.
Alright, I gotta end it before it makes the 40-minute mark.